today we're going to see how we obtain a block diagram from a bond graph. You see there's a mechanical system on the screen on the top left corner in there, and so from the bond graph model of this system we should be able to get the block diagram. Okay, how do we actually start over here? What I want to say is this. We are going to use a one junction for each distinct velocity that we find. Like for example in here you have this, we define this as, let's say, x1, and you define this as x sub 2, like that, yeah. So for each distinct velocity we put a one junction. So this is x1 dot, and this 2 is x2 dot, yeah. All right, so now what we have is the basic, and we're gonna say x1 also for the velocity of the wall, which is equal to 0, right? And then the second step I'm going to do is to attach the elements that see these relative velocities in there. I mean, to see these velocities. So in here we have this I element, which is the mass with value m sub 2. We have in here I element with value m sub 1.
The red's 1.
Huh?
Is that a 1? Yeah.
This is a 1, yeah. And this is a source of flow, which we're gonna say this is a source of flow. Hold on for a second. Let me make sure we do this right. So this would be is source of flow with value velocity of the wall equals to 0, yeah. And then you see this is the, so we put the elements that see those velocities, but you see in between this one and this one we have these two elements, and in between this and this we have this element. Let me add one more thing in here that I think would give it a little more interesting here. Let's put a force in here, and that means you're going to have a source of effort with value F, which is into the system. Okay, very good. If you apply this is going to move. So the difference between x sub 2 and x sub 1 is represented by this zero junction. So this is x sub 2 dot minus x1 dot. And this element is in between those. So that's this element, which would be a C element with value 1 over k sub 2. Alright. Over here we got the difference between this and the wall. So this is 0 here. And this would be a one junction with x1 dot minus velocity of the wall. And then in here you have the C element with value 1 over k sub 1, and you also have this R element with value b sub 1. This is the bond graph model that we are about to enter into this. We want to create this block diagram from this. in here we can reduce this a little bit so as to the bond block diagram also to reduce, and this we can reduce it in this area here. We can reduce it here and here, and in a couple of, no, actually on this one and here, those two. Okay, so we could do this. We could say, okay, if you reduce that, this would be a 0, and the SF over here, like this would be a 1, and it would have, actually it'd be nice to just write it like this, the C, and then this R element, and then you have this 1 which has the I element over here like this, and then you have this 0, and in here it directly will have just the C. The 1 would be, what do we say, I, and then you have this SE. Okay, given this, you know, it reduced a little bit, but not very much. Velocity of the wall here, and then we have to put some numbers here. So why don't we just put numbers? I'm just gonna change colors to do that so that make it very distinct. This is 1 and 2 and 3 and 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then you have let's see, let me complete this. We need to complete all the, you need to either be giving at this point or complete the causal marks to have to be able to do the block diagram. So if I'm gonna, you know, if the question comes up of getting the block diagram from the bond graph model, this is what you'll be giving. You'll be giving a bond graph model. So what do we do next? But I think you will get a bond graph model that is complete. And then let me put those marks in here. This is because remember those marks, they have meaning on how the equations of the system go. See, this is like that. Okay. So we'll study later on in more detail how to put these marks in here, but for now, given this, the question is, what do we actually, how do we actually do this? Okay. Very good. I think it would be a good idea to just write the steps that we go through. We say, okay, why don't we put in here, we're going to begin a list of steps and do my block diagram on the right hand side over here. So I'm just going to say, see, I probably need a little more space. So okay. I'm gonna say steps. Okay, so I just need to put the so the first step is going to be to build a skeleton of the, you would say, let's say, you would say, based on the bone graft structure. You would say set two signals. You would say signals per bond. What do I mean with this? This particular case, you'll have, I think I'm gonna do it a little bit farther down in here. So this is your, this would be E sub 8, and then this would be F sub 8. And then you have two, see, we started anywhere really, two signals. One is E sub 9, and the other one is F sub 9. Okay. And in here we're gonna say you have two, this two, this is E10 and F10. So here we go, this one, you'll have, and this is, what number is that?
7.
Alright, that's number 7. This would be E sub 7 and F sub 7. And then you have the I element on this side in here. And that is going to give us what? This would be that, what is the, it's gonna give us, that would be 6. So this is going to be like E sub 6 and F sub 6. And then we have this other two in here, which is E sub 5 and F sub 5. And then we have this E sub 3 and F sub 3. And finally here there is a E sub 2 and F sub 2. So you see I'm laying out the skeleton of my block diagram. I forgot one here, see? This is the E11 and F11. Yeah. So that's that. And we have one more here. This is the SE. So this would be E1 and an F1. And then we have the, we also have one over here, see? Just do it nicely here. Yeah. Okay. Having established this, you may say this backbone, Now we start building it. All right. We could go from left to right or start anywhere, really. It doesn't matter. All it matters at this point is that we do the individual constitutive relations. So I'm just gonna put maybe a step number 2 that we will put over here. I would say 2 I'm gonna say draw log diagrams of individual constitutive relations. All right, there we go. So in here, this one is easy one because in here you have this effort. I mean this is F, this SE, with value F over here. And out of here, you know that this is coming out like this, and this other one is coming in like this. Yeah. Okay, we have a small error in here. We weren't watching the right hand side of the screen, so we got to erase this because E sub 2 is the one on the right, so not the one that I was putting in there. So you see, this is an I element where the output of this is the flow and the input is the effort. So how does it go here? What you do is you are going to multiply by 1 over I sub 3, and this thing you're going to integrate once. 1 over S, and then out comes F. So that's that one. The one on the SC is the one that is a source of effort or force in here, which goes into the system like that, and this comes in. So that's the constitutive relationship of this one. The one over to this side on 4, it says that E sub 4 is the one going out. How do I know that? Because see, this E is away from the C. And in here, how does that happen? The first thing it happens is you come and multiply by 1 over C sub 4, and then you integrate it by 1 over S. See, and out comes E sub 4. So, and we go about doing it each element. We have done this one, we have done this one. Let's try the I. The I is over here, right there. The flow is what goes out. And you say, how do I know? Because you see the flow going out right here, the effort going in. So in here, how does this work? We're going to multiply by 1 over I, so 6, and then you have this 1 over S, like that. Okay, and then we have to do these 3 that are remaining. Let's do the C, this one on the bottom in here. The output of this is E11, like that, and the input is F You say again, how do I know that? Because of this causal mark that it gets the output out of the C element. So in here we have a gain that this is 1 over C sub 11. Yeah, and then we are going to have an integrator over here, 1 over S, and then, yeah. So that's the C element. The R element, the flow is out, so that's this one. This is in. And what do we know about this? We know this is R, so E, this would be 1 over R. Yeah. And then you have, we are almost done with the elements. We only have the source of flow, which is like this on the side. The source of flow is what goes out like that. That's like this. And this is SF with velocity of the wall equals to 0. So you see it begins to take shape now. I am going to change colors just to illustrate that what I'm going to be doing now are the connections. So you see the connection here of this one first. All the flows are the same because that's what one junctions do. So you see we join this like this. But the efforts will add. So that is in here. Yeah. So, and how is it plus or minus or what is it? You see the output is here. This is plus this. Yeah, the output is E sub 2. So you have that this minus this is this. So this is plus, this is a minus. All right, now this other connection, all the efforts are the same because it's a 0. Now we put this one in like that. But the flows will add. See how it's left a little hole in here to do? And then this is, now the question is, which one is the input, which is the output? The way you're seeing here is the flows F3 comes in. Oh, this was left from when I was doing the drawing here. All right, let's fix this. All right, you see the flow is coming in like this one. And then the effort is going out like this. Yeah. Okay. And then E5 is this way. And then F5 is like this. So on this one right here, we have F sub 3 minus F4 equals F5. But the way the equations are written here, the output is F sub 4. So it's gotta be F sub 3, which is this, minus F5 Yeah, because the way the equations are written for this is like you have like E1 is equal to E sub 2 plus E sub 3. This other one over here, you have for the flows, the way this is written is like F sub 4 is equal to F sub 3 minus F sub 5. And then this one over here, you have that the efforts will add, so you have E sub 6 to E sub 5 minus E7. And then we have two more. Like on the 0, you have that F9 is equal to F sub 7 minus F sub 8, like that. And finally on the one junction down there, you're saying that F7 minus F8 is F9. F7 minus F8 is F9. That's right. Now what we're saying here, we're saying that E sub 8, E sub 9, excuse me, is equal to E10 plus E11. With this relations of the junctions, we can draw things here. Because now this one here that we have on number 6 for the I, yeah, all the flows are the same. So that means this has to connect like this. All the flows are the same. But all the efforts with sum. Yeah. And how do they sum? In here, you see that E sub 5, the output really of the one is E sub 6. So okay. So do we do plus or minus, or what is it? The way it's written is E sub 6 is E sub 5, which is plus, and then minus 7, which is this minus, like this, okay? Yeah. And then finally we have this last two to do. Like in this case, here the flows are the same. The flows are the same, so I would say this goes over here. Okay, but the efforts will sum. So we're going to sum the efforts. See, everything comes out all right in the end. So this is right here. You have that E9 is equal to E10 plus E11. The way this is written here is like E9 is the output. Yeah, so E9 is E10 plus E11, so this would be plus. So we're done here. We are done just to one of the, you see how it took shape now? We're down to this junction. All the efforts the same, so put them all the same. Yeah, but the flows will add, so the flows will go in here where F7 is. That is okay, that's on this side over here. So these flows are the same here. No? What did I do here? Here's a little trouble. These are all the is on this. All the flows are the same, so that's right. Okay. No, this is correct. All I was trying to determine are the signs here. So the way this is written, we have to look at this. There is one line that is not correct here, and that's this one. Yeah. This goes over here like this because it adds. It adds or not? No.
Maybe that sum.
Yeah, the sum is not correct. So let's, in this zero up here, the efforts are the same. So this is right, like that. But I'm gonna draw it a little farther away so it doesn't get confused. Yeah, like that. And this other one. Okay. So in here, the flows are going to add, right? So my problem is that this part is not quite conducive to that addition here. We need to fix this a little bit. See, now that that hole is in there, then this is correct. There you go. So the flows add up over here. How is the way this is being written is like the flow F9 is the one that comes this way, and F7 comes like this. And F8 also. So this is like F9 is the sum of those two. Then you're fine. Okay. So what we have now is an entire block diagram that represents the bone graft model in there. You can have it like this.